Okay, so in this tutorial we're going to try and do the big one. We are going to try and draw a full network diagram for critical path analysis from scratch. Now don't start panicking. This is not something you're going to get asked to do in the exam, but we've had so many requests from students asking us to do a tutorial on critical path analysis. And the only way to understand it is start at the very beginning. So have a look at this table that we've got on screen here. It shows us three different columns. It shows us some activities that are going to be involved in a project. And we're going to label those up A, B, all the way through to J. But imagine they represented things like completing some market research, hiring employees, training members of staff. So those are all activities that are involved in a project that a business is completing. The middle column says preceded by, and that shows us what activities have to be finished before another activity can take place. So for activity B, for example, you can see that that one cannot happen unless A is already finished. That's what preceded by means. In the final column, we've got how long each of those activities is going to take us. So if we use that little table, we're going to try and get going on drawing a network diagram. So this diagram is going to start with a node, which is just a circle. We're going to split it into three, and we'll write some information in there later. First thing we'll do is give this node a name. We could call it Steve, Frankie, Mike. We're actually going to call it node number 1, and the only purpose that really serves is so that later on we can actually discuss the information in those nodes and we can call them by names. Okay, so we'll start with node number 1. Now what we're going to try and draw first of all is what happens with activity A. If you have a look in our table, you'll see that activity A is not preceded by anything. So activity can start right from the beginning, right from the go. And we're going to draw on a little line there to indicate that activity A is going to take place. We'll label him up, give him its name, and we'll put on 4 there, and that 4 means that activity A is going to take 4 weeks to complete. And what we'll do is we'll pop another node on there to finish activity A off. So that node number 2 that's now appeared on screen indicates that activity A is completed and we're ready to start something else. The something else that we're ready to start is activity B. You'll see from our table that activity B cannot be completed, cannot even start until activity A is finished. So coming out of node 2, we'll draw activity B. We'll write on that it takes 2 weeks, but crucially that comes out of a new node, node number 2, which indicates that activity A is finished and now activity B can begin. We move down our table to activity C. You'll see that that's preceded by activity B. So we'll draw ourselves node number 3. That comes at the end of activity B to indicate that B is now finished. We can label C on there. We'll draw a little line to indicate that activity C can take place, and that one takes us 3 weeks to complete. We move down onto the next section of our table. We'll see that activity D is not coming after activity C. It kind of starts its own new branch. That little dash in the middle column there indicates that just like activity A, activity D can start right at the beginning of this project. So we'll label it up D, we'll write that it takes 6 weeks on there, and we'll move on to activity E, and we'll draw node number 4 there to indicate that activity D is now finished, and anything that comes out of node 4 is a new activity. So we'll put activity E on screen. The 2 indicates that it takes 2 weeks to complete, and we've got another section of our network diagram done. We move on to activity F. That one's going to follow on from activity E. So node number 5 can be drawn on screen there. That finishes off activity E and gives us a place where we can start activity F. So you can see we've got 2 branches now that shows that A and D can both begin right away, but B can't begin until A is finished, and C can't begin until B is finished, and then the same along that middle row. D begins straight away, but E is reliant on D having finished first, and F is reliant on E having finished. We move down to activity G. That's perhaps our most interesting one yet. Activity G is reliant on 2 other activities being completely finished before G can start. Now the way we're going to draw that on our diagram there is we're going to put node 6 on, and we're going to draw up both activity C and F, both flowing to node number 6. And out of node 6 we'll have activity G. We'll write on that it takes 4 weeks, and by having 2 lines heading to node 6 for both C and F, we're indicating that G cannot kick off until both of those other activities are completed. We go down to activity H, we'll see that he's just like A and D. Activity H can kick off right at the beginning of this project. Crucially, this one only takes us 3 weeks to complete. We'll draw a node to finish H off so that I can then come out of it. And you'll see that I just takes 4 weeks to complete. And then we get on to our last activity, activity J. Now we're going to use node number 8 to tie up all of our loose ends there. We're going to have activity G and activity I both flowing into node 8. And the reason for that is because if you look in the table at activity J, and activity J could be something that comes at the end of a project, like the launch event. But that event cannot happen until not just G is finished, but I is finished as well. That's why they both flow into activity. They both flow into node 8 to indicate they both need to be finished. We'll pop J at the end there. We'll see that that one takes 2 weeks, and we'll draw one final node to budge our table across there to show that this activity is now completed. So node number 9 is our last node. Nothing's going to flow out of it. J is the last activity as part of this project, and it has completed. It has finished. Now the next thing we can do is to try and add some data into our nodes, and we're going to use the top right hand quadrant of each node to pop in what's called the EST, which stands for the earliest start time. Now that's going to show us the earliest time that each of these activities can begin by, so the absolute earliest week that they are able to kick off. Now we'll start that in the top right hand quadrant of node number 1. So you can see there, this is where we're going to write in its EST. And we're going to write in 0. That means that this project doesn't even need to wait for the first week to be finished by. These activities, A, D and H, can all kick off from the very first minute, from week 0, from the very, very outset. We move across our diagram. We have a look at node number 2. We're going to write in the top right hand corner there the very earliest time that our next activity can begin by. So we'll look at activity B. So our activity A can begin on week 0, but activity A is going to take 4 weeks. The way we work out the earliest start time for activity B is to take activity A's earliest start time, add on to that the duration of activity A, and that will tell us how many weeks will have to have elapsed before activity B can start. So activity A's earliest start time is week 0. A is going to take us 4 weeks to do, so 0 plus 4 equals 4 weeks, and that is the absolute earliest time that activity B can start. Now the reason why activity B can't start for 4 weeks is because you'll see from our table B cannot get underway until A is complete, and if A takes 4 weeks, then that is unfortunately the earliest time that B is going to be able to start. We move along again, we can work out the earliest start time for activity C. So always in our nodes, we're writing the earliest start times of the activities that are about to follow. You'll see that if we take B's earliest start time of 4 weeks and add on the duration of B, which is 2 weeks, 4 plus 2 equals 6. So we write in 6 weeks as the earliest start time for activity C. We head on to the middle branch, we can have a look at D. D can begin on week 0 but takes 6 weeks, so we'll write 0 plus 6 in as the earliest start time in node 4. That means that 6 weeks is the earliest time activity E can kick off on. We'll do the same for activity F and put an earliest start time for that one in node 5. So we'll take E's earliest start time of 6 weeks, add on E's duration, which is 2 weeks, and 6 plus 2 equals 8 weeks as the earliest start time for activity F. Now, first little tricky bit that we've got here is going to go in node 6, because you'll see that we've got 2 different branches flowing into it. So writing the earliest start time for activity G in the top right hand corner of node 6 is a tricky task. Are we going to use the numbers that we've got from the top stem of our critical path diagram, or are we going to use the numbers of our middle stem? Well, here's the rule. The earliest start time of an activity, if you've got more than one choice, you always go with the largest of the numbers. So let's see how that could work. We could take the earliest start time of activity C, which is 6 weeks, and add on the duration of activity C, which is 3 weeks, and have 6 plus 3, which equals 9. But that would be a lower number than if we had a look at the middle stem. And if we took activity F's earliest start time of 8 weeks and added on the duration of 2 weeks, that number would actually be 10. And with our earliest start times, we always go with whatever is the largest option. What that means is for activity G, although activity C could be done by week 9, that's no use for activity G. Because activity G's got to wait for not just C to be completed, but F as well. And if F can't be completed until 10 weeks in, unfortunately G cannot start until 10 weeks in, which is why we go with the larger number when we've got 2 or more options for our earliest start times. We go down the bottom now and we do the earliest start time for activity I. You'll see that H's earliest start time is week 0. H only takes 3 weeks to complete, so the earliest start time for activity I is that 3 weeks. 0 plus 3 equals 3. If we go for node 8 again we've got a couple of different options. We could take the 3-week earliest start time of activity I, add on the 4-week duration that I is going to take us to complete, and say that in node 8 the earliest start time for activity J is 7 weeks. But unfortunately that's simply not true, because although J can begin once activity I has been completed, it's also got to wait for G to be completed as well. Now G is not even getting underway until week 10, and it takes 4 weeks to complete, so that's 7 weeks we have to remove, and we have to go with 10 plus 4 means that activity J cannot begin until week 14. We'll finish this off by just popping 16 in the final node. That's the earliest start time of activity J of 14 plus the duration, which is 2 weeks, which means that the final earliest start time we write in there is 16 weeks. Now, because there's no activities coming out of node 9, that's not really the earliest start time of anything. That 16 weeks represents the very quickest time that we could get this project done by. So if we run everything as efficiently as we can, we now know that this project could be completed in 16 weeks. Time to finish our diagrams. What we're going to do is we're going to write information in the bottom right hand node. We're going to write what's called the LFT, the latest finish times, in here. Now that is the latest week that each of these activities have got to be completed by. Otherwise, if they're completed any later, they're going to hold up the entire project, mean that we can't finish it in the 16 weeks that we had planned. Now with our earliest start times, you can see that the earliest start time for each activity goes in the node to the left of it. So the earliest start time for activity D is shown in node 1 before D is drawn out of it. The latest finish times actually go in the node after an activity is complete. So we'll pop 16 in there. That 16 is the latest finish time for activity J. So its earliest start time for activity J is written in node 8, 14 weeks, and its latest finish time is written in node 9. That's 16 weeks. Now, as we calculate these latest finish times, we're very simply just going to take the latest finish time from the activity before. We're going to deduct the duration of that activity, and it's going to give us the latest finish time to write in the next node. So you can see for J, we've got 16 as its latest finish time. We're going to deduct the 2-week duration of activity J, and that means that in node 8, we're going to write that the latest finish time for activities G and I, you can see that they both join up to node 8, is 14 weeks. If we go down to that bottom strand, we can do the latest finish time for activity H. So we're going to take the 14-week latest finish time that we've got written in node 8. That's the latest finish time for activity I. We're going to deduct the 4 weeks that I takes, and that tells us that the latest finish time for H is 10 weeks. If we jump into node 6, we can do the latest finish times in that node for activity C and for activity F as well. So the way we're going to do that is we're going to take the 14-week latest finish time that's written in node 8. We're going to deduct the 4-week duration of activity G, and that gives us 10 weeks, which is the latest finish times for C and F. We go from the middle of those 2 rows now. We'll try and work out the latest finish times, first of all for activity E. We're going to take the 10-week latest finish time from node 6. We're going to deduct the 2-week duration of activity F, and you'll see that we put 8 as the latest finish time for activity E. We'll carry on going up to the top. We'll do it for activity B now. We'll take that 10-week latest finish time for activity C. We'll deduct the 3 weeks that C takes, and you'll see that the latest finish time for activity B is 7 weeks. Jump back down to the middle. We'll do the 8 latest finish time from node 5, take away the 2-week duration of activity E, and that means that we're going to write 6 as the latest finish time in node 4. So that 6 is the latest time that activity D can be completed by. If we just jump back up to our node number 2, one at the top there, we'll work out the latest finish time of activity A. We're going to do that by taking the 7 weeks latest finish time from node 3. That's the latest finish time for activity B. We're going to deduct the duration of activity B, which is 2 weeks, and 7 minus 2 equals 5. So 5 weeks is the latest finish time of activity A. We finish that off by just putting the final latest finish time in node number 1. Now here we've got some different options, and again we've got to work out which one we're going to put in there. So if we go to our very bottom strand, we could do the 10-week latest finish time from node 7 minus the 3-week duration of activity H and write in 7 for node number 1's latest finish time, but that would be inaccurate because what we want to do with latest finish times is try and write in the lowest option available. So we could also, if we wanted, take the 5-week latest finish time in node 2, deduct the 4-week duration of activity A and write 1 in the bottom right hand corner of node 1, but that would be incorrect as well because it's not the lowest possible number we could write in there. What we want to do is to take the 6-week latest finish time from node 4, deduct the 6 weeks that activity D is going to take, and we write a 0 in node number 1. So now we've got a completed network diagram with earliest start times and latest finish times on there. Crucially, we want to move on to what we might get asked to do in the exam, and that's to calculate float times and identify critical paths. So let's have a look at how we do those, two things that are very closely linked. Let's have a look at activity A first of all, which is going to take us 4 weeks. Now to work out whether activity A has any float time, we're going to have a look at its earliest start time, its duration, and its latest finish time. And if this activity does have any float time, it means that it has got the potential to overrun without holding up the project as a whole. And if it has any float time, it means it's not on our critical path. It's not one of our activities that are critical to complete on time in order to prevent us holding up the entire activity. So we'll pop our earliest start time and latest finish times on the screen there for you. And you can see that for activity A, it can kick off on week 0. It's going to take 4 weeks, but doesn't have to be finished until week 5. So we can see that that's got a week that it could overrun by. It's got some slack, it's got some potential to overrun. It's got some leeway, if you like. It's what we call float time. So it could start week 0, could feasibly, as it only takes 4 weeks, get done by week 4, but it doesn't have to be done until week 5 because other activities elsewhere on the diagram take longer. So that means it's got some float time. It's not going to be on our critical path. We'll do the same for activity B. We'll throw on there its earliest start time and its latest finish time. We'll see that it can begin on week 4, takes 2 weeks, so could really be done by week 6 if it goes as efficiently as possible. But it doesn't have to be done until week 7. As long as it's done by week 7, we can proceed without it holding up the rest of the project. So again, we've got a week's float time here. So this is not part of our critical path. We'll put the earliest start times and latest finish times for activity C. We'll see we've got the same situation again. Can kick off on week 6, takes 3 weeks to complete, could really be done by week 9, but crucially doesn't have to be done until week 10. So it's got a week's float time, which means it's not on our critical path. When we have a look at activity D, we'll see that things are a little bit different. If you present its earliest start time, which is 0, and its duration, which is 6 weeks, you'll see that its latest finish time is exactly 6 weeks as well. This means we've got no potential to overrun on activity D. We've got no leeway. We couldn't overrun even by a day. If we did, we wouldn't be able to get done in our 16 weeks. So we take our earliest start time of 0, add on our duration, And if that is equal to our latest finish time, it means that we have no float time, we have no slack. So we're going to put a little double strike through here and see down the bottom, and we're going to keep a little running tally of what's on our critical path. D is our first activity on there, no float time for activity D. We move on to activity E. You'll see that the earliest start time is week 6. It's going to take 2 weeks to complete activity E, and it's got to be done by week 8. No float time, no slack, no leeway. Can't kick off till 6 weeks. Going to take a fortnight to complete. Got to be done by week 8. No potential for overruns here. We'll double strike through. E makes it onto our critical path. We'll do activity F. Kicks off on week 8. That's the very earliest it can start. Gonna take 2 weeks. Latest it can be finished is week 10. There is no potential overrun here. There is no float time. Double strike through. F makes it onto our critical path. We'll do G. Early start time of 10 weeks. Latest finish time of 14 weeks, but takes 4 weeks to complete. 10 plus 4 is equal to the latest finish time. Double strike through. G makes it onto our critical path. Have a look at activity H. We've got a completely different story again. We've got an earlier start time of week 0. Activity H can begin right from the very outset. Only takes 3 weeks to complete and doesn't have to be finished until week 10. We have got 7 weeks of latitude on this activity. Could overrun by 7 full weeks and still get done by week 10, which will prevent us holding up the project as a whole. So because H has float time, does not make it onto our critical path. Same story for I. You'll see this earliest start time is week 3, only takes 4 weeks to complete, feasibly could be done by week 7. Look at the latest finish time, doesn't have to be done until week 14. We've got another 7 weeks of float time. The people responsible for activity I have got enough time for a Caribbean cruise, and they can still make it home in time to get it done by week 14. We've got plenty of float time, doesn't make it onto our critical path. Crucially, J does. Earliest start time is week 14. Got to be completed by week 16, otherwise the entire project's going to overrun. Crucially, J is going to take that full 2 weeks. 14 plus 2 equals the latest finish time. We've got no float for activity J, so we double strike through it and we have got our full critical path for this activity. So the critical path is all of those activities that did not have a float time. That indicates to us the pathway of activities that are crucial to get done on time. The ones that are critical, that they do not overrun. If D, E, F, G, or J overrun by a day, or a week, or a month, it means that the entire project is going to overrun. Whereas A, B, and C had a small amount of float time, and H and I both had a more generous amount of float time. That is how we draw ourselves a critical path or a network diagram. It's a complicated process. You're not going to get asked to do that in the exam, but you could get asked to amend one of these diagrams. I firmly believe that you will not understand how to amend one of these diagrams unless you know the full story of how they are constructed. That'll do us for today. In another tutorial, we'll look at how you make amendments to critical path diagrams and how it might change the critical path. But for now, keep on taking the biz. Good luck with your critical path revision.